Good morning, everybody. Welcome to the Blair Witch Project. Good afternoon, everybody. Welcome to the JavaScript programming language. I'm Doug Crockford of Yahoo, and today we're going to talk about JavaScript. These are the things we're going to cover today. We're going to cover the history of the language. We're going to talk a lot about the language itself and some of its advanced features. We'll carry that on in the advanced JavaScript class that will follow. We'll talk about some of the platforms where JavaScript is available. We'll talk about the state of the standards, and we'll talk about programming style in JavaScript. JavaScript is without a doubt the world's most misunderstood programming language, and this owes to a number of factors. First off, the name. It has Java as its prefix, so a lot of people think that JavaScript has something to do with Java. Maybe it's interpreted Java or a subset of Java or something like that. It turns out it's none of those. JavaScript is almost completely independent of Java. It's a different language. And the suffix script suggests that it's not a real programming language. It's something, again, diminutive or not complete. But in fact, we're going to see JavaScript is a complete programming language. In fact, it's a pretty good one. It was intentionally mispositioned at its creation by Netscape and Sun Microsystems, and we'll talk about that history. The language contains some design errors, some of which have been corrected during the course of its evolution, some have not. And so it's a very popular language. It's probably right now the world's most popular programming language if you consider all of the platforms in which it's deployed. But the language has problems, and we'll look specifically at those problems. Early on, there were very bad implementations. And the language received a very bad reputation as a result of those bad implementations. The implementations have gotten good, quite good in fact, but the reputation of the language remains damaged. The language has been typecast. It's known primarily as the language of the browser. And so the browser, as we'll find out in the class, the theory of the DOM, is a really hostile programming environment. A lot of people think that the thing that makes the browser so difficult to do is JavaScript. But it turns out JavaScript is not the problem there. We'll look at that as we go along. The books about JavaScript are almost all universally bad. So it's very difficult to learn the language from books, because most of the books are full of bad advice and bad examples. There's only one book that I recommend, and that's Dave Flanagan's Definitive Guide from O'Reilly, the 5th edition. I can say without fear that it is the least bad of a very large class of very, very bad books. So yeah, it's that one, the Rhinoceros book. I recommend it as highly as I can recommend a JavaScript book. The standard which defines JavaScript was defined by ECMA, the European Computer Manufacturers Association. We'll talk about them later. Unfortunately, the standard itself is not very good. It's very difficult to read and understand, which contributed to the bad book problem, because authors could not go to the standard in order to improve their understanding of what the language does. Finally, JavaScript is a functional language in the way that Lisp and Scheme are functional languages, which puts JavaScript in a completely different class. But this is virtually unknown. So we'll be talking about this aspect of the language as we go forward. In 1992, Jim Gosling was sitting in his office at Sun Microsystems. He had been working on a language which was going to be a successor to C++. Gosling's a really smart guy, but not very good at naming things. And so his working title for the language was C++++. His friends told him, Jim, you can't call it that. You're going to have to call it something else. So he looked out of his window, saw an oak tree. And at that moment, the name of his language was changed to Oak. Gosling then got spun out into a new startup called First Person, which was going to be developing technology for interactive television applications. And Oak was used in those applications. That company failed. So in 1975, he was rolled back into Sun. After having failed in interactive media, they were sitting around trying to figure out, well, what do we do with Oak now? And in a conversation in a coffee shop, they decided that what it really needed was a new name. And so looking at the menu, Gosling decided to call it Java. At the same time, they decided that one of the first applications they would demonstrate of this new language was a web browser. because the web at that moment in time was starting to become hot. So they called the browser Hot Java. Having that browser having almost the same name as the language that it was written in caused huge confusion, which actually helped them. There was so much hype at the time about how wonderful browsers were and how wonderful Hot Java was, and that caused a huge amount of excitement about the language itself. Meanwhile, at Netscape, they had looked at Java and decided this really isn't going to work in web pages. It's way too heavy, it's way too clumsy. To do APIs in web pages and to do form validation and the sorts of applications that they anticipated, they wanted something much, much lighter. Brendan Eich was at Netscape at the time. His first idea was to do a dialect of scheme in the browser. His manager said, no, there's no way the market will accept all those parentheses. Do something that looks like Java or Visual Basic. Don't do anything weird. Just do a nice little scripting language and we'll let you do that. So he decided to base his syntax on Java and created something which became known as LiveScript. LiveScript was the first scripting language to be put into a web browser. It was also the first scripting language to be put into a web server. The LiveWire platform that Netscape was developing at that time had LiveScript in the server. The reason Netscape and Java were so exciting at the time was because it was thought that they were going to provide a way to escape from Microsoft. If the web could be established as a way of writing applications in which we're no longer dependent on operating systems, then we can get free of Microsoft and the world will be a better place. That created huge energy around both companies. They came to the conclusion that they were more likely to win against Microsoft if they joined together. If they didn't join together, then Microsoft would beat them against each other and would prevail. So they decided to create an alliance. And the stickiest part of the potential alliance was what to do with LiveScript. Sun wanted Java to be the language of the browser. It would be the way that we would add interactivity to the web. Netscape said, that's fine, except it doesn't work. So we really need to stick with LiveScript instead. There was a big battle about that. The alliance almost fell apart. Then Mark Andreessen, the founder of Netscape, had a really devious idea. He changed the name of LiveScript to JavaScript. I think he thought it was funny. I think it was a way to poke Sun in the nose. What happened instead was Sun claimed trademark ownership of JavaScript, and so they had control of the name going forward. So the next year, 1996, Microsoft looked at what was happening with JavaScript and said, okay, we need to knock that off. So they reverse engineered JavaScript, did an extremely careful job in their reverse engineering. They did not want to deal with Sun about the trademark issue, and so they called their implementation JScript. A lot of people think that JScript and JavaScript are different but similar languages. That's not the case. They are just different names for the same language, and the reason the names are different was to get around trademark issues. For the same reason, Microsoft changed the name of their implementation of Java to J++. It wasn't because J++ was intended to be a different language, it was just intended to stay away from Sun's lawyers. Netscape was alarmed at the fact that Microsoft had made a copy of their language and that Microsoft would probably go and mutate the language and they would lose control over it. So in order to prevent that from happening, they decided we need to make it a standard so that Microsoft won't be free to fiddle with it. So they took it to the European Computer Manufacturers Association, or ECMA. You might be wondering, why would a software company in California go to the European Computer Manufacturers Association, which is headquartered in Geneva? The reason was they thought they could get a rubber stamp there. But what happened was when the meeting started, Microsoft was a member, as were a number of other companies. And from the first day, Netscape lost control of the standards process. And Microsoft pretty much dictated the course of the language from that point on. In particular, mistakes that Netscape had made in the first version of JavaScript, Sun had copied in their reverse engineering of JScript and insisted that those errors remain in the standard. Because it was very important to Microsoft at that time to never do anything to cause anybody's program to break. Now, they never apologized to me when it caused my programs to break. But in the ECMA committee, That was a really important thing. And so those problems persist in the language, and we'll look at some of those today. Now, the good news about JavaScript is that it is not a web toy. It is a real language. It's a useful language. It's a powerful language. It is small but sophisticated. And it is not a subset of Java. It's a completely different language. And if you can learn to think about it in the way that it's particularly strong, it's a very effective language. Every programming language has a key set of ideas which should be distinct from any other language. Otherwise, there's no reason for it to exist. These are what I think are the key ideas in JavaScript. The first one is load and go delivery. That means that programs are delivered to the execution site as source code. In other languages, programs are delivered as executable files or as abstract class files or something like that. JavaScript gets delivered as text. The reason for that is it was originally intended to be embedded into web pages. Web pages are text, and so if you can put programs in the same medium, it's really convenient. That's no longer the preferred way of delivering programs to browsers, but that mode still exists in JavaScript. Second was loose typing. This is really controversial. A lot of the fashion right now is in strong typing, allowing compilers to check as much as possible before the program gets deployed. Loose typing, though, has overwriting benefits. There's much greater expressive power. Often programs tend to be easier to write. In this case, you don't get a choice. The language is loose typing. So if you can learn to like loose typing, you'll be more effective. It has objects as general containers. This was a brilliant idea. We'll talk a lot about this, where they have the unification of objects and hash tables. So objects are completely dynamic things in which new members and new methods can be added at any time. Another key idea is prototypal inheritance. This is really distinct from classical inheritance, which we see in most other languages. In prototypal inheritance, objects inherit directly from other objects. There are no classes. This turns out to be a really powerful idea, but it's not commonly understood very well. So you see a lot of people trying to program in classical styles in a class-free language, and that's not effective. But if you can learn to think in terms of prototypes, JavaScript can be extremely effective. The next powerful idea is Lambda. Lambda is the use of functions as first-class objects. This is something that we first saw in Lisp and Scheme. JavaScript has it. Really powerful idea. We're going to talk a lot about that. And then finally, linkage through global variables. Because of the load and go model, JavaScript doesn't have any sort of linker. So separate compilation units are all combined in a common global namespace, which turns out to be a really, really bad idea. It has security problems, reliability problems, and other things. We'll talk about how to mitigate those. The JavaScript language has a small set of values. Those are numbers, strings, booleans, objects, and the special values null and undefined. We'll look at each of these. There's only one number type in JavaScript. There's no separate integer type. There's just number. And it's represented internally as 64-bit floating point, which is also known as IEEE 754, which is also known as double, which I think is a stupid name for a number type, but that's what it's called historically, because Fortran had something called double precision, and the name stuck. The problem with floating point is that it doesn't map well to common understanding of arithmetic. So 0.1 plus 0.2 does not equal 0.3. So you need to be really, really careful when you're dealing with things like money, because people expect it to add up right. And floating point can only give you an approximation, generally, of decimal fractions. So what you want to do, if you're dealing with cents or with dollar values, is multiply them by 100. That way you're dealing in whole cents, do the arithmetic, and then scale it back. There's a special value called nan, which stands for not a number. It is a result of undefined or erroneous operations. For example, if you divide something by 0, the result will be nan. It's toxic, so any arithmetic operation which has nan as one of its inputs will have nan as its output. So if you go through a whole series of computations, and at the end of all those equations and statements, you find a result is nan, that tells you that someplace there was a problem, but it doesn't give you a very good indication as to where that was. Nan is not equal to anything, including nan. So nan equals nan is false. Also, nan is not less than nan, and nan is not greater than nan. Nan is a really perplexing value. Also in JavaScript, even though nan stands for not a number, it is a number. If you ask the type of a value that is nan, the result is number. There's a number function which can convert a value such as a string into a number. That's handy if you have something that you take out of a form field. Generally, a text field will be text. You need to turn it into a number before you can do arithmetic on it. The number function will return nan if the string cannot be converted into a valid number. JavaScript also has a plus prefix operator which does the same thing, and we'll see that later. There's a parse int function which is specialized for just parsing integers. And generally, you should always include the radix argument, which tells it what base to calculate in. The reason for that is it stops at the first non-digit character that it sees. And if the first digit is 0, it is allowed to interpret it as an octal constant. And so a leading 0 could cause it to think it's octal, and then the next digit is not an octal digit, and so you get a result of 0 rather than a result of 8. So for that reason, I recommend when you're using parseInt, always use a radix. One mistake that JavaScript copied from Java was having a separate math object. Java did that so it could easily jettison math for applications in which you didn't want to pay for having a math library. But it turns out that's just not useful, and JavaScript repeats the same mistake. So there are a number of useful mathematical functions available. These are some of them. Probably the most useful of them is going to be the floor method. Math.floor is the thing you use to take the integer part of a number. JavaScript has strings, where a string is a sequence of 0 or more 16-bit characters. The encoding is, in Unicode speak, UCS2, not UTF-16. That's because JavaScript was created before Unicode got to that level of maturity. The difference between those two is that UCS2 is not aware of surrogate pairs for the extended character range. Now, it turns out the extra million characters are very rarely used, so it's generally not a problem, but it's something to be aware of. There's no separate character type in JavaScript, so if you want to talk about just one character, it's just a string of one character. It's just a short string. It's not a separate type. Strings are immutable, which means that once a string is made, it cannot be modified. So you can't go into the middle of an existing string and manipulate the characters. You have to make a new string, which you can easily do by concatenating together pieces of old strings. Similar strings are equal with the double equal operator, which is good. Java got that wrong. And you can write string literals in either single quotes or double quotes. Both work the same way. There are no magic quotes or semiquotes or anything like that in this language. All strings have a length member, which you can use to determine the number of 16-bit characters in it. This is not necessarily the same as the number of Unicode characters in it, again, because it doesn't know about UTF-16. There's a string function which can be used to turn a number into a string, and there are also number methods which can do it maybe a little bit more gracefully. Strings also have methods. Strings are objects in this language. So there are lots of useful methods that you can perform on strings to get characters from them or extract substrings or search on them or perform other sorts of surgery on them. You'll be glad to know there are exactly 2 Boolean values in JavaScript and that they are true and false. A lot of languages can't make that claim. There's a Boolean function which will take a value, and if the value is truthy, it returns true, and if the value is falsy, it returns false. We'll talk in a minute what truthy and falsy mean. Then there's null, which is the value which isn't anything. That's sometimes a useful thing to have. And then there's undefined, which is the value which isn't even that. Undefined is the default value for variables. So if you define a variable and don't initialize it, it gets initialized for you with the value undefined. This can be really confusing because a variable can be both defined and have the value undefined at the same time. I think maybe they could have picked a better name for this because it's trying to describe two states at once. Undefined is also the value that you get when you extract a member from an object that doesn't have that member. So it's the missing value, undefined. So I talked about truthy values and falsy values. These are the falsy values: false, null, undefined, the empty string, the number 0, and nan. All other values, including all objects and everything else that we're going to see in the language, are truthy. The ones to watch out for are the string 0. It's not the same as the number 0, so it is truthy. Also, the string false is truthy, even though it looks like it's false, because all non-empty strings are truthy. Yes? That's a good question. Case sensitivity. All of the keywords that we're going to see in the language are lowercase. There are some methods we'll see which are camel case, but generally it's all lowercase, and it is case sensitive. So those are the simple values. Everything else in the language is objects. So you may have heard that JavaScript is not an object-oriented language. I'm going to try to convince you that it is, because it's all about objects for the rest of the day. So in particular, the style of object which is implemented in JavaScript is the dynamic object, the unification of objects and hash tables. The new object constructor produces an empty container of name-value pairs, where a name can be any string and a value can be any value except undefined. So once we create an empty object, we can augment it by adding new members to it. Members can be accessed with dot notation or with subscript notation. Objects provide both syntaxes, which is a little different from most other object-oriented languages. Now, even though these things behave like hash tables, there's no hash nature visible. By that I mean there's no hash codes or rehash methods or anything like that. And in fact, in the JavaScript implementation in IE, they didn't even bother to implement hash tables. They've got linked lists for these things. So for some object operations, it runs noticeably slower on JavaScript than in other implementations. JavaScript is a loosely typed language, which means that any variable is capable of receiving any kind of value. And any parameter to a function can receive any kind of value, and any kind of value can be returned from a function. The language is not untyped. The language actually has a pretty robust sense of what types are, but it's very loose in that it allows any type to be used anywhere. JavaScript is syntactically a member of the C family. It's got all the curly braces and everything. It differs from C mainly in its type system, which allows functions to be values. That's one of the big ideas in JavaScript and what distinguishes its syntax. Its identifiers follow the same rules as most of the C languages. An identifier starts with a letter or with an underbar or with a $, and is followed by 0 or more letters, digits, underbars, or $signs, and the name will be case sensitive. By convention, all variables, parameters, methods, and function names start with a lowercase letter, except for constructors, which start with an uppercase letter. And we'll talk about constructors later. Initial underbar is reserved for implementations. They seem to be really popular in a lot of people's programs. I don't know why. Doesn't seem to be any reason for them. Generally, it's better not to use them just to make sure you don't have a conflict with some internal variable. $sign was added to the ECMA specification specifically for machines, meaning macro processors and program generators, things like that. So it's recommended you not use $signs in your own programs. However, some of the Ajax community has fallen in love with $signs, and they're using $signs all over the place. So if you want to ignore the standard, you can go ahead and do that. JavaScript has a bizarre reserved word policy. All of these words are reserved, but only the ones in boldface are actually used in the language. They got really heavy-handed in what they chose to reserve. Also, they apply this list in places where they shouldn't have. When you retrieve certain things using the dot notation or member names, cannot be reserved words. This was just an error in the language which has not been corrected yet. There are two styles of comments in the language. You can do / as a prefix, or you can do / as a bracketed comment. It has the same set of operators that you would expect to see in any C language. Most of them work the same way as they would in any other C language, but there are some differences, and we'll go over those. The plus sign is used for both addition and concatenation. The rule is if both operands are numbers, it adds them, and otherwise it turns them both into strings and concatenates them. This was a mistake. In a language which is loosely typed, having this kind of operator overloading was just dangerous. And we see a lot of mistakes made from this. For example, you see that expression where you're trying to concatenate a $sign to an addition, but you end up concatenating it all together. So you need to be careful that when you intend to add, that the operands are numbers. Plus can also be used as a prefix operator, which will convert an operand into a number. So plus the string 42 yields the number 42. We can add strings together by using the plus operator. The reason I put this one in parens was this one could be confused with plus plus, which means something completely different, and we don't want that confusion. So it's best to avoid that construction. Division of two integers can produce a non-integer result, so you need to watch out for that. So 10 divided by 3 isn't 3, and it isn't exactly 3 1/3 either. It has equal and not equal operators. Unfortunately, these operators can do type coercion, which can interfere with producing the correct result of the comparison. There's also a triple equal and a bang double equal operator, which do exact equality of both value and type. And I recommend you use those instead. Netscape at some point recognized that they had made a mistake. And so the way they wanted to correct it was to fix double equal to be exact and added triple equal to the language to be coercive. But Microsoft said, no, we don't want to do that, so they reversed it. So language now requires triple equal when you want exact equality. It's a little harder to type because you have to go bang, bang, bang instead of bang, bang. But the programs will run a tiny bit faster and will probably be a little bit more reliable. JavaScript has a logical AND operator, which is also known as the guard operator. It works a little differently than it does in some of the other C languages. If the first operand is truthy, it returns the second operand. Otherwise, it returns the first operand. It doesn't necessarily return true or false. It can be used to avoid null references. So I've got an if here. If A is truthy, then I'll return A.member. Otherwise, I'll just return A. I could write this here just as return A guarding A.member. Does the same thing. It's a lot smaller, a lot faster. Similarly, there's a logical OR operator, which is also called the default operator. And it works the opposite as the other one. So if the first operand is truthy, the result is the first operand. Otherwise, the result is the second operand. We can use this to fill in default values. So here we've got an input that we may have pulled out of a form element. And we want to assign a value to last. If input has a value, that's what we'll put in there. But if input is falsy, we'll put that in there instead. So we could write that as an if statement. This is much more compact. And if you get used to thinking of this as default, then it's a really expressive way of writing these sorts of expressions. It has bang, the logical not operator. If the first operand is truthy, the result is false. Otherwise, the result is true. If you say bang, bang, that'll produce a Boolean. Because when you do that and do it again, you'll get either true or false. It has bitwise operators, and you might wonder, what sense does a bitwise operator make in a language that doesn't have integers? So the way they work is they take the floating point number, convert it into a 32-bit integer, do the logical operation on it, then convert it back into floating point. So some people, when they use these operators, they think that it's going to go faster. You know, if I'm going to do a shift instead of multiplying by 2, that's going to be a big win. In this language, don't do that. If you don't intend for a bitwise operation, don't use these operators because it's going to be slower. JavaScript has a large set of statements which look pretty much like the set of statements that you'd find in any of the other C languages. But there are a few differences, and we'll look at those. First off, it has labeled break, which is a really nice thing. I copied this from Java. So I can put a label on a loop, and then I can break from that loop. And so if I have nested loops or nested switches, I can bust out of the middle and get down to the bottom. It's really handy. It has a for statement, which we can use to iterate, for example, through the elements of an array. So if I have an array called array, I can go through its length and visit all of its members. And in the body of the loop, array sub I will be the current element being considered. There's also a special version of the for statement, which is for objects, which allows us to iterate through all of the keys that are in an object. The syntax is a little bit different. We say name in object, and for each iteration through the loop, name will be set to one of the keys from that object. Unfortunately, we'll also go through all of the keys of all of the objects that this object inherits from, which is usually not something that you want. So to avoid against that, you have to write as the first statement of the for, if the object has that property, then we'll do what we want to. Otherwise, we probably want to reject it because it's something we're dredging through the inheritance chain. This is an annoyance, and a lot of people who ignore this pattern end up having programs that get broken when they work with other people's programs. So this is a disgusting thing you have to do, but I highly recommend that you do it in all of your for statements. JavaScript has a switch statement just like the C languages, which provides a multi-way branch, but it has some advantages. First off, the switch value does not need to be a number. It could be a string or anything else. That's really, really handy. And the case values do not have to be constants. They can be expressions, which could also be handy. So for example, I could have a switch statement in which I'm comparing against strings. And you know, if I match one of those and I do that, it still has the same broken switch statement as everything else in that you have to explicitly terminate each of the clauses. That's unfortunate, but that seems to be the standard. And then it also has a default, so you can catch all the else cases. JavaScript has a throw statement, so you can throw an exception from your code. You can generate an exception object by calling the new constructor. Or you can use an object literal and make one in place if you don't want to go to that trouble. And we'll talk more about object literals as we go on. Once you throw, you might expect that the exception will be caught. So JavaScript has a try statement. You can try some bit of code, and if an exception is thrown in it, it will be caught in the catch clause. Because we don't have classes in this language, there will only be one catch clause. You won't have one per exception class. And your catch clause will then have to determine what sort of exception it is and decide if it wants to handle it or throw it on or whatever. Any questions about that? Okay. And there's a try statement, there are exceptions which are built into the JavaScript system itself. So the JavaScript engine knows how to throw all of these exceptions. And all of these exception constructors are available to you as well, so you can throw any of these, or you can make up your own exceptions. JavaScript has a with statement, which was intended as a convenience for dealing with objects. but there's an error in the way it was conceived, and so I don't recommend you use it. It's ambiguous and error prone. So here's an example. We have a with statement with some object, foo equals null. Now, it could mean o.foo equals null, or it could mean the global variable foo means null. Anybody have a guess as to which one it means? Well, it turns out you can't tell. It could do either of them, depending on what O is. So programming is hard enough. If you're using constructs in which you can't predict when you read the program what the program is going to do, best not to use it. So I recommend stay away from the with statement. JavaScript has a function statement, which is used for declaring functions. A function has a name, an optional set of parameters, and then a set of statements which get executed when the function is invoked. There's a var statement which defines variables within a function. You don't specify types in this language, so you don't say int a or something like that. You just declare that it's a variable. Optionally, you can initialize the variable with values. So I can say var number of errors initialized to 0, or I can just give a list of variables separated by commas. Now, if you don't give an initialization value, it will be set to undefined for you. In JavaScript, blocks do not have scope. This is a departure from all of the other C languages. I think maybe it was a bit of laziness when they were writing the compiler. This causes people to think incorrectly about variable scope. There is only function scope in JavaScript. So if you declare a variable any place inside of a function, it's visible everywhere in the function. And if you declare a variable twice in a function, it only gets created once. There's no error for that. Yeah, so this was a mistake, and the mistake persists in the language. So, yeah?
It also implies that I don't have to specify my variables in a single place.
Right.
Does it also mean I have to declare my variables?
That's another good question.
You just use the name and have it appear.
JavaScript has implied globals. So if you,
Ouch.
yeah. So we'll talk about these more later.
Yeah.
But if you create a variable and forget to declare it, JavaScript assumes that you meant it to be a global variable. So for example, if you forget to define I, you've created a global variable called I. And if you make that same mistake in 2 places, there's a good chance your program is going to fail. JavaScript has a return statement, actually 2 forms of them, one in which it returns an expression and the other where it appears to return nothing. Except in JavaScript, every function will return a result. There is no void type in JavaScript. So if you have a function which does not return something explicitly or falls through the bottom, that function will return the undefined value, except in the case of constructors, in which you'll return the new object. And we'll talk about those in a little bit. So we said everything else in the language is objects. And objects can contain data and methods, and objects can inherit from other objects. So objects in this language are collections. An object is an unordered collection of name-value pairs where the names are strings and the values are any type, including other objects. It's very good for representing records and trees. You can think of every object as being a little database. We also have an object literal notation in this language, which is extremely convenient. It provides a way of conveniently creating a new object. Again, the names can be strings, but names can also be simply names. So in some cases, the quote marks around keys are optional. The values can be any expression. Colons separate the names and values. Commas separate the pairs. Object literals can be used anywhere that a value appears. So here's an example of an object literal. I declare a variable called myObject, which contains this object, which has a name and a goto and a grade and a level. So you can think of it as creating this little table in memory in JavaScript. where these are the keys and those are the values. And then I can access that material in the language. I can say my object.name, and that will set the name to Jack Be Nimble. I can also use the subscript notation. I can say my object sub, the name or the string go to, and it will do the same thing, put jail into the destination. So these two notations are interchangeable in most cases, except they're not in this case, because goto is a reserved word. And one of the errors in JavaScript is that I cannot have a reserved word in this position, but I can have a string in that position. So that's why you need to be aware of the reserved word policy. Another way that I could make an object is to have a maker function. So I'll pass a bunch of material to the maker function and have it make an object for me and then return it. So in this case, I've got a maker function which will create an it variable, and then it will fill that object up. Or here, the empty curly braces mean make a new empty object. So I then assign to that object a name, a goto, a grade, a level, and then I return it. Okay, so the other way I could have made my object would be to call a maker function and then pass the material that I want it to construct with. Now this maker function could get arbitrarily complex. Instead of just taking the values it's passed and doing stuff with it, it could go do computation or call other functions or look at other variables or whatever in order to decide how to build the thing. But this is sort of the simplest kind of function that makes an object. So here's we've taken that same object and we've made the object a little bit more complicated because we've added a format field to it now. And its type is an object. So this shows an example of how we can have nested objects in this notation. But all crunched up like that, it could be really hard to read. So this can be a lot easier to understand if you take advantage of pretty printing. Let's see. In this case, it's very clear what the structure of this object is going to be.
What was the question?
The question was, could I have a trailing comma here? And the answer is sometimes, so no, really. We'll look at an example later of how that becomes a problem. So we can use an object literal any place we can expect a value. So any place in the language where we could have any kind of expression or variable, we can stick one of these in there too. So I can pass an object to my function, and my function doesn't know if this was a predefined thing or something I defined on the spot. It just gets an object with all those values in it, and that can be pretty handy. Or here again, I'm going to throw an exception. An exception object should have a name type and a message. I can just make it dynamically. I don't need to create a constructor or a call constructor to throw an exception. I'll confess I once wrote a really horrible API in JavaScript. I had, it was some years ago, I had a superdiv constructor which took like 10 or 20 parameters. And it was really hard to remember what the names of all the parameters were. And it turned out most of the time you didn't need all of them. And then later we figured out that some of them really shouldn't have been parameters at all. They should have been in style and so shouldn't have been in this list. But by then the API was stuck and we couldn't take them out without breaking it. Had I been smart, what I would have done instead was pass an object to this thing. And that object would allow me to have what would practically be named parameters. It wouldn't matter what order they're in. It could detect when things are missing and provide suitable defaults. It would have been a much cleaner API. So generally, if you find yourself doing something with more than a couple parameters in it, step back and think about refactoring it as something that takes a single object. One of the nice things about objects in this language is that they can be augmented. By that I mean you can take an existing object and add new stuff to it at any time, give it new members, new methods. And we do that simply by assignment. So if I want to make an object that is bigger, I don't need to make a new class. In fact, there are no classes. I just do it. So if I decided that I wanted to add a color model member to the format of this thing, I just assign it, and boom, it's got it. So the general pattern is I have an object, a key for that object, and a value that I'm assigning. And this works anytime for any object. When objects are created, they're created with a secret link to another object. This is the method by which inheritance is achieved, because objects are able to inherit from other objects. If we attempt to access a member from an object and that access fails, the system will silently go to the object that that object was linked to and see if it has a member with that name. And if it does, it returns it, and computation goes on. If it doesn't, then it will finally return undefined. The secret link is not used in storing. So if I store something to an object, it goes to that object. We never go down that chain. We can use the object function to make a new empty object which has that linkage to object O. So this is the basic fundamental operator in prototypal inheritance. We'll talk a lot about how this works. So let me put in a picture for you. Maybe it'll make it clearer. So I'm going to make my new object, and I'm going to have it inherit from my old object by making it with the object function. So what it creates in memory is a new object, which is an empty object, which contains the secret pointer to my old object. Then I can go ahead and start augmenting this one. So I can assign it a name. That creates a name in this object. No change to this one, because I'm doing the assignment to this one. Okay, then I'm going to increment its level. Now this one initially didn't have a level. So it went to this one. It's got a level, 3 plus equal, add 1 to it, store it here. That creates a 4 here. And then again, I can augment it by adding another thing here. But the other, let's see, if I ask this, my new object what its grade is, there's no grade here, so it'll return A. It inherits that value from this object. So linkage provides a simple inheritance mechanism. Any object can inherit from an older object. Some languages have classes, methods, constructors, modules. JavaScript has functions. And JavaScript's functions do the work of all of those things. Instead of classical inheritance, we have prototypal inheritance. It accomplishes the same things, but it does it differently. It has, I think, greater expressive power, but it's different. If you don't understand that it's different, it's going to be really frustrating. So instead of organizing objects into rigid classes, new objects can be made that are similar to existing objects and then customized. Object customization is a lot less work than making a class, and it's a lot less overhead. One of the keys to doing that is the object function. The other key is functions in general, and we'll talk about how those work. Yeah?
What happens to the new object if the old object is set to undefined?
That's a good question. What happens to the new object if the old object is set to undefined? Let me go back a little bit. OK, so suppose we say my old object equals undefined to make it go away. Well, this object still exists. So my old object was a reference to this value. This value still exists. So this linkage is not broken. But the other thing that could happen is I could change this guy's grade to B. The value this guy inherits is now B. So he can be sensitive to the dynamic state of this object. Or I could delete the grade member from this. Now he no longer has a grade. Yes? That's a good question. So what happens to this 4? Once the level is stored into this object, we no longer look at this one. So this one's level is now self-determined. One thing which is a little odd, though, is if this guy ever deletes his level, he'll now have this level, because this one will now shine through again. So sometimes deleting things doesn't cause them to disappear, it causes them to appear to mutate. Yes? It's only single inheritance, so you only get one of these arrows per object. But as we'll see, you can have long linkages of these objects. Yes? Is there any way to change the linkage after the fact? There is in Mozilla. They have a non-standard thing, and we'll look at that briefly in the advanced JavaScript class. I don't recommend it because it's not standard and it won't work anywhere else. And I think it's probably a bad idea anyway. Yeah?
Does JavaScript cope with circular linkage?
Does JavaScript cope with circular linkage? You can't, because an object can only be made from an existing object, and those linkages cannot be changed. So there is garbage collection in this language. You'll be glad to know that, and it's mark and sweep. So cycles do get reclaimed. Okay, so you can have this link going to another object in which you inherit properties. The end of that link chain is always directly or indirectly object.prototype. It's always the last in the chain. So object.prototype is a place in the system where the system provides built-in methods for you. It turns out that they're not very useful, unfortunately. There is one that we saw earlier, has own property, which is a little bit useful. Surprisingly, there is no copy method for objects in JavaScript. It seems like an omission just doesn't have it. Also, it doesn't have an equals method in it, which also seems like an omission. You can use the equality operator, which tells you if two references are the same object, but it doesn't tell you if two objects contain the same stuff. JavaScript just doesn't have that. It seems odd, but they don't. So there are three ways in which we can make a new empty object, which we can then stuff full of good stuff. We can use the new object constructor, or we can use an empty object literal, or we can call the object function passing it object.prototype. All three of these will do exactly the same thing, return exactly the same result. I recommend the empty object literal because it's the smallest, and once you learn to read it this way, it's also the most expressive. Objects can be passed as arguments to functions. They can be returned by functions. Objects are always passed by reference. They are not passed by value. The double equal or triple equal operator compares object references but not values. So it will return true only if both operands are the same object. It doesn't help if they're similar objects. There is a delete statement which can be used to delete elements from an object. You say delete the object and then sub the name or dot the name, and that removes it. Actually changes its value to undefined, which does the same thing. Objects or arrays in JavaScript are unusual. They're not like in most other languages because array inherits from object. The way arrays work is that array indexes are converted into strings and then used as names for retrieving values. They're not the position indexes into a list or a string of memory. It's really efficient for sparse arrays and not very efficient for almost all other applications, including the ones that we write. It does have one advantage, though. There's no need to declare the length of an array when you're creating it, because it doesn't matter. And you also don't have to give the type of the stuff going into the array, because that doesn't matter either. Yes? What's the threshold of sparse? Pretty sparse. You know, if you've got like 1% population in your array, then this is a really effective way to do it. For anything in which memory tends to be pretty linear, this is not an efficient implementation. Arrays have a length member, which tells you, which looks like it should be the number of elements in the array, but it's not. It is one larger than the highest integer subscript, which, depending on the composition of the array, may or may not be the same as its actual length. So what that does is allow you to use a traditional for loop to go through all of the members of the array. So the length operator does that, or the length operand or member does that. There are array literals in this language, which work similarly to the object literals. An array literal is in square brackets with values separated by commas. So here I can make my list, which contains these 3 vegetables. And then I can append to an array. Since arrays don't actually have a length, they don't actually have an allocation, we can add new stuff to any array at any time. So if I assign to my list at mylist.length, this will be 3. So we assign the third subscript, give it barley. That changes the length of the array to 4, because the length is always 1 bigger than the last index that we assign to it, or the last biggest that we assign to it. We can't use the dot notation with arrays because there's a confusion with dots and numbers, but we can use the subscript notation. And empty brackets is the preferred way to create a new array. Recommend you don't say new array to create a new array. Yes?
Basically, it creates the same object when the hash names are 0, 1, 2, right?
That's a good question. Does this create something similar to having an object literal in which the keys are quote 0, quote 1, and so on? Very, very similar. The difference is that it also has array nature, which means that the length member means something, and it also inherits the array methods, and we'll look at those. Otherwise, it's the same stuff. So arrays have methods. These are some of them. We can concatenate arrays together. We can join an array, which means we turn all of its members into strings and concatenate them all together. We can push and pop things on the end, so we can treat it like a stack. We can slice it, sort it, splice it. We can do surgery to it. We can delete members from an array by deleting them the same as we can with objects, but it doesn't do what you think it does. It removes the element from the array, but it leaves a hole. It doesn't change the subscripts of the other members. If we want to get rid of a hole, we need to use the splice method. So let me show you an example of that. I've got an array containing A, B, C, and D. I delete subscript 1. Because arrays start from 0, we end up with this structure. The indexes of these two didn't change. If we want to close up the hole, then we could use splice, which says starting from the first index, delete one thing and insert nothing in its place. So that will then give us this result. So since objects and arrays are so similar in this language, I mean, they're almost the same thing. When to use one and when to use the other. In fact, if you use the wrong one, your program will probably work most of the time, so you don't get good feedback when you're making a mistake. So this is how you decide. Use objects when the names are arbitrary strings, and use arrays when the names are sequential integers. Don't be confused by the term associative array and think that means you use an array. In this language, arrays and objects are both associative arrays, but the thing that you think that an associative array is the object. Yeah, right. Okay, so we talked about how objects have these secret links by which they inherit things. Arrays also have secret links, and they get linked to array.prototype. You don't get to choose with arrays, and we'll talk about the implications of that later. So if you get a value, how do you determine if it's an array or if it's an object? As we'll see later, there's a type of operator in JavaScript, but it doesn't help us to do this distinguishing. So there are two methods that do work. One is we can say value.constructor, does it equal array? The other is we can say array instance, or value instance of array, and if that returns true, then we can think it's an array. Although neither of these work if the value came from another frame. And we'll talk later about why that is. This is an omission in the language, which I'm hoping gets fixed someday. Okay, so we can't really use, we cannot inherit from an array effectively. So you can't use arrays as prototypes. The reason is that the thing that gets produced by the object operator is going to be an object. It's not going to have array nature. The length member isn't going to work. It won't be right. But what you can do is you can augment an individual array by assigning methods to it. Since it is underneath an object, it's able to receive any kind of value, including functions, and any kind of key, not just numbers. The other way you can augment an array is to augment all of the arrays in the system at once. And you can do that by assigning methods to array.prototype. We'll look later about how that works. OK, so functions are first-class objects. First of all, in the computer science sense, functions can be passed and returned and stored just like any other value. This turns out to be really, really powerful and important. But also, in the sense that JavaScript means an object, a function inherits from object and can be a container of name-value pairs. This sounds really strange. How can a function contain members? A function could contain other functions. What does it mean for a function to have methods? We'll look at this. Okay, JavaScript has a function operator, which we use to create function objects or function values. And it takes an optional name and a parameter list and a block of statements. It looks a lot like the function statement. But we can use this any place in the language where we can have an expression. So we can pass functions to other functions. We can assign functions to variables. We can store them in objects. We can return them from functions. Very, very powerful. What JavaScript calls a function, other languages have called lambda. It's a source of enormous expressive power, and unlike most power constructs, it's a secure construct, where it's not the kind of thing that blows up in your hand. It's something which can actually constrain scopes and help you to keep your programs in check. Now, earlier we saw the function statement, which looks a lot like the function expression. And it turns out that one is just a shorthand for the other. So when you say a function statement, what you actually end up doing is creating a variable and assigning a function value to it. The function statement is a shorthand. So this function foo expands to creating a foo variable which has that function as its value. Some people get confused about, can I have functions with the same names as variables? Do they interact with each other? The answer is yes. There's one namespace for both of those things. Functions do not all have to be defined at the top level or on the left edge of the screen. Functions can be defined inside of other functions. That turns out to be a really useful thing, but it raises questions of scope. What does a function know and when does it know it? So the rule is an inner function has access to all of the variables and parameters of the function it's contained within. This is known as static scoping or lexical scoping. The other way to do this is dynamic scoping. Turns out for most applications, static scoping is better. So this is one of the things that JavaScript got right. The scope that an inner function enjoys continues even after the parent function has returned. This is called closure. Now, this sounds really weird. What does it mean that it still has access to a parent's function after the parent function has returned? What's it mean? Let me show you an example. This is something that's really popular right now in Ajax applications. We're going to change the color of something from yellow to white. We're going to do it with a fade function, and we'll pass the function the ID of an HTML element. And so we'll define a couple of variables. We'll define a DOM variable, which will contain a DOM element that we fetch based on that ID. And we'll create a level variable, which we'll set to 1. And then we'll create a step function. Never mind yet what it does, but we'll create a step function. And then we'll call set timeout. And what that does is, in 100 milliseconds, the system will call the step function for us. And then the fade returns, and it's finished. It's all done. So the parent function has returned. Suddenly, 100 milliseconds later, the system wakes up and calls the function that we passed in here. OK, so what does it do? It defines h, which is the hex value of the level. What is level? It's that. It is the value of the parent's variable. And then it gets the computes the color for the DOM background color. What is DOM? DOM is that variable. So it has access to that variable. It's not the value of the variable at the time that the function was created. It's actually got a connection to that parent's variable. So down here, we look to see if level is up to 15 yet. And if it's not, we will increment it. It's not incrementing a copy. It is incrementing that variable. Okay, it still has access to it. And then it will arrange to call itself again in another 100 milliseconds. And we'll keep doing this until it gets up to 15, and then it stops. Now, what happens if we want to fade two things at once? Okay, so I'll call fade on that and fade on that. Will those two calls of fade interact with each other? No, because each of these functions, when it's invoked, has its own scope. And so we can have multiple invocations of fade going at the same time. They will not interfere with each other because all of these are local variables to the fade function. So we'll talk about closure and inner functions and this a lot more in the advanced class. But this is probably the #1 really powerful feature in JavaScript. This is something that formerly we only saw in AI languages. Really, really good stuff. This is the thing that makes JavaScript worth your attention and why we can afford to look past its other failings, because this is the first Lambda language to go mainstream. This is something that the MIT guys have not been able to do in 40 years. So this is really, really good stuff. OK, functions are objects, so they can contain name-value pairs, just like other objects. This could serve the same purpose as static members do in some of the classical languages. So if we have a maker function or a constructor which acts like the constructor of a class, it can contain methods and other things which are useful to the class. And since functions are values, they can be stored in objects. And when a function is stored in an object, we call it a method. If there are some rules on function invocation. If a function is called with too many arguments, the extra arguments are ignored. And the function just receives the values it asked for. If a function is called with too few values, then undefined is used to fill in the missing values. There is no implicit type checking of the arguments, and there's no checking of the number of arguments. So you're pretty much on your own there. There are 4 ways to call a function. There is the function form, the method form, the constructor form, and the apply form. We'll talk about the apply form some in the advanced class, but we'll talk about the first 3 here. First, let's look at the method form. Here we've got an object on which we're invoking a method. Then we have dot or a substring, the method name, and the arguments. When the function is called in this form, in addition to its regular parameters, it gets a special extra parameter called this. And this will be bound to this object. So it gives that function access to the object that it was invoked in. This allows the object to have that reference and allows us to reuse functions in lots of different objects or in different inheritance chains. And it depends on the invocation to tell it which object it's linked to. Then there's the function form, in which we don't have a function prefix on that. We just have a function value that we're calling. In this case, this gets bound to the global object, which is not very useful. And it could be argued this was a mistake in the design of the language. One of the ways it's a mistake is that it makes it really hard to write a helper function inside of a method. Because the helper functions in the method don't have access to the this of the parent. So one way we get around that, if we need an inner function to have access to this, is we define a variable called that and assign this to that. And then the inner function can use that because that will be available in closure, in scope, and we can use it. It's annoying that we have to do this. Again, it's another error in the design of language, but it's in there. And finally, there's constructor form. And it looks like function form, except there's a new prefix. When a function is called with the new operator, a new object is created and assigned to this. So it's another implied parameter going into the function. If the function does not have an explicit return value, then this will be returned by the function instead of undefined. So to summarize, depending on the invocation form, this can be either the global object or the object from which the method was obtained or the new object being constructed. In addition to this, functions also have access to another special parameter called arguments. So when the function is invoked, an additional parameter is given to it. Arguments is an array-like object which contains everything that was passed to it. So we talked about how if there were extra arguments, they get ignored. They don't get ignored now. The arguments array will deliver everything that got passed. So it allows us to loop over everything. We can actually check the number of parameters in that way. Unfortunately, it's not a real array in the way that JavaScript is. It's an array-like object. So it doesn't have access to the array methods. Its length attribute doesn't really work. It's a bit of a problem. So here's a way to use it. Say I want to write a sum function. And I'll pass it any number of numbers, and however many numbers it gets, it's going to add them all up and return the result. So we're going to set n to be arguments.length, and then we're going to loop till n, and as we go, we're going to get the next argument and add it to the total. And then we're done, we return it. So this provides a convenient way of writing functions that take a variable set of parameters. So one of the really powerful things in JavaScript is that we can extend the built-in types. I can extend all of the objects at once by extending object.prototype, or I can enhance all the arrays by assigning to array.prototype, and so on. So let me show you an example of this. A trim method is a method on strings which will get rid of white space at the beginning and the end of strings, clean them up. Unfortunately, JavaScript neglected to include such a method, which is unfortunate because that's a really useful method. But it's not a problem because I can write one. I can assign to string.prototype.trim this function, which contains a regular expression, which gets passed to the replace method, and it will do what I want. It'll look for a pattern of white space and non-white space and return something from the middle, and I get exactly what I want. Here's a slightly more complicated example. I've got a template string which has some meta variables in it, and then I've got an object literal here with some interesting data, and I'd like to be able to blast this data into that template and then stick it into the DOM tree. This is really easy to do. This is a very nice model of client-side HTML generation. Unfortunately, JavaScript doesn't have a supplant method. But fortunately, it's really easy to write one. So again, I can go to string.prototype.supplant, and then I've got another function, which again calls replace, does a slightly more complicated thing on it. basically I'm passing to replace a function which tells it how to do the substitution. And again, it has access through closure to the object that gets passed into supplant. So being able to augment the basic types of the system is really powerful. I mean, in Java, you can't even extend string. Here, we're not extending string, we're fixing string. We're making string do exactly what we want. That turns out to be really powerful. JavaScript has a type of operator, which helps us to determine what the type of something is. So if I put type of in front of an object value, it returns the string object, which is pretty good. Unfortunately, if I put it in front of an array, it returns object, which isn't wrong, but it's not very helpful. It doesn't distinguish that it's an object. Even worse, if I pass it null, it returns object. That is wrong. That's just a mistake. And I asked Brendan Ike, how did that happen? And he said, in the first implementation of JavaScript, he had tagged pointers. And the tag value for objects was 0. But he also used null for null pointers, which also happens to have zeros in that spot. He didn't notice it, but the guys at Microsoft did, because they copied that bug into JScript. And they insisted that it stay in the standard. JavaScript has an eval function. This is powerful and dangerous. Eval gives you access to the JavaScript compiler and interpreter. So you can pass eval a string, and it will compile the string and execute it in the context of the function that's calling eval. That makes eval extremely dangerous. It's the most misused feature of the language. Recommend you don't use it ever. If you ever find yourself in a situation where you feel you just have to use eval, give me a call. Let me talk you out of it. Okay? Don't be using eval.
Hey, you have to tell us why it's dangerous.
When you find you're needing to use it, I'll explain it to you.
Okay.
Well, there are a number of things wrong with it. One is it wastes a lot of time. Often you're calling the compiler to do something which could have been done much easier. That's probably the biggest misuse. We find that there are a lot of cases where people don't know how to use the subscript notation. So instead, they will concatenate dot notation things together and then eval them. It's probably the slowest way of doing those sorts of things. Also defer certain kinds of checking to runtime that could have been done at compile time or at authoring time. So it delays error detection. So it makes it easier to ship bugs. So, and there are also security problems with it. Yeah.
If you're using JSON, do you have an option to not use eval?
Yeah, the question is, should you use eval with JSON? Turns out that is the only time when it's correct to use eval. And then it's only correct if you can absolutely trust your server. Not only that its intentions are good, but that it is not incompetent. Because if the server is acting as a proxy and sends bad stuff without filtering it, then it's wrong to use it in that case too. So if there's any doubt about the competence of your data source, then you need to use the parse JSON method instead of eval. He says always doubt. That's good advice. There is also a new function in JavaScript, which also gives you access to the compiler. In fact, this is the thing that eval calls. In fact, the reason eval is in the language, why would they put such a dangerous thing in the language? The reason is the browser uses it. So when the browser gets a script tag or the browser sees an event handler on the page, the browser calls eval saying, well, what should I do with this? So it was there for its convenience. They exposed it to us as well. It's probably better that they hadn't, but they did. So eval calls the new function, and it takes a string, which is the body of a function, and it compiles it and returns a function object, which is then executable. This shouldn't be used for the same reason that eval shouldn't be used. And I see it misused in exactly the same ways. Java has both int and integer types. One of them is a simple value and the other is an object which wraps that simple value. I think it makes Java unnecessarily complicated. JavaScript copied that pattern to absolutely no advantage. The occasional reasons for why it was useful in Java made no sense in JavaScript. This is now recognized as an error in the language, so don't use it. Don't ever be saying new Boolean or new string or new number. This is particularly a problem from people who are coming from Java because they're used to saying new string. But this doesn't do the same thing. This creates an object which wraps a string value, which isn't the same as a string value. This one is particularly troublesome because if you say new Boolean of false, its value is false, but the value is truthy. So you don't want to go there. It's confession time. I've been telling you about using the object function to create objects. It turns out JavaScript doesn't have that object function. It's a prototypal language, but they failed to implement the core operator that you would have in a prototypal language, which is make another object based on another object. They instead did a very complicated thing with constructors and prototypes interacting with new. All of that stuff can be encapsulated into this one call, though. And in the advanced class, I'll explain why this function works and why you should use it. But just so you know, if you go typing in object and it throws it back at you, it's because you need to type this in first. OK, so one of the powerful things about JavaScript objects is that we could augment them. We can directly modify individual objects and give them just the characteristics we want. We can do this without creating classes. And then we can take our new objects and use them as the prototypes for other new objects, which we can also augment. I think of this as working with the grain, that deep down JavaScript is a prototypal language. And if we can learn to think prototypally, then we can use the language much more effectively. And in the advanced class, we'll be talking more about the prototypal and parasitic inheritance patterns, which are really effective in this language. We don't need formal classes in order to get code reuse or extension in this language. Just don't need it. JavaScript has a global object. We talked about how one of the problems with JavaScript is that instead of having a linker, everything gets resolved in a common global namespace. That namespace is the global object. It is implemented as a JavaScript object, and it is the object that dares not speak its name. And by that I mean it doesn't have a name in JavaScript. It is the global object, and it's important, and it's omnipresent, and it's always there, but there's no direct way of saying that and always getting at it. Sometimes this points to it. For example, we saw in function form invocations, this gets bound to the global object instead of to something useful. So it is possible to get access to it, but it's not reliable. On web browsers, the global object is the window object. And the way they made that work was they assigned to the global object a window member whose value is the global object. And so when you say window dot something, that goes to the global object, finds window in it, which points to itself, and then it knows what to do. So if you ever wondered, is it faster to say document dot something or window dot document dot something? It's faster just to say document, because when you say window, you're actually doing one more loop through the lookup thing than you had to do. You end up getting to the same place. Well, it turns out one of the reasons why this is a really bad idea is that global variables are evil. The functions within an application can clobber each other, and cooperating applications can clobber each other. So the use of global namespace has to be minimized. Otherwise, there's a good chance that as our programs get bigger, or as we mash up, or as we work with libraries or other components, we're going to get failures. The problem is intensified by another error in JavaScript, which is the implied global. Any var which was not properly declared is assumed to be global by default. This makes it real. This was intended to make it easy for people to program, so you didn't have to know about defining variables. You just write. And if your program never gets bigger than that, that's probably not a problem. But we're now writing programs in JavaScript which were much bigger than what were originally anticipated. And in the current world, implied globals are a big problem. One of the ways we can protect ourselves from that is to use a program that I wrote called JSLint, which is basically a JavaScript compiler written in JavaScript, which will go through your code and look at all of your scopes and your definitions and help you find out where your globals are and other stuff. So I highly recommend that you put your programs through JSLint. We'll talk about that more in a little bit. So JavaScript's got this global namespace, and we know that's bad. But we've got tools for dealing with that. For example, we've got objects, and every object is its own namespace. Every object has its own distinct set of names. So we can build our own namespaces using our objects. So one of the things we're doing at Yahoo now is we have declared a Yahoo object, which is the one global object that we need. And everything else that we're doing gets stored hierarchically inside of that object. So that way we can have lots of stuff written by lots of different groups and different properties. They all go to a registry to make sure that they don't interact in that space. And then we can have confidence that we're going to reduce the collisions with our advertisers and with third-party libraries and user scripts when we get them and all that other stuff. So if you're at Yahoo, highly recommend you be using the Yahoo object. You can read about it here on the Twiki. If you're not at Yahoo, don't be using the Yahoo object. Make up your own object. We recommend that you pick an all uppercase name because that's the least likely to accidentally get used. Put all your stuff in there. Again, if we can all try to reduce as much as possible the number of global variables we're making, we also reduce the likelihood that we're going to collide. Yeah?
Do namespaces inherit?
Do namespaces inherit? They can, in the sense that namespaces are just objects, and objects can inherit. So you could make a super Yahoo object, which inherits from another Yahoo object.
Next question, does super exist?
Super does not exist in this language. The other thing we'd like to be able to do is encapsulate. And function scope can be, yes?
Regarding the global variables, like I have a question is, if you have an HTML file, right, if you're including like 2 JS files in it, does it count as one global namespace?
That's a really good question. So you've got an HTML file, and that file might have some JavaScript in it, and it loads additional scripts. How does it all get bound together? All of those scripts all become part of one space. All of those scripts become part of one space. I'm sorry?
That's where you get killed.
Yeah, that's the problem. I think that was one of the big design errors in the language. So that's why it's so important that we look at these methods for trying to mitigate collisions in this environment. So the other thing we can do is take advantage of function scope. One of the rules of scope is that variables defined inside of a scope are not visible outside of the scope. And so that gives us a very nice way of doing encapsulation. In fact, we can use an anonymous function to wrap our application. Now we'll look a lot more at this in the advanced class. I'll just give you a preview of how this works. Suppose we want to create a trivia service. We decide that it's important to put a trivia question on every page we put out. And so in the Yahoo object, we create a trivia object which will be responsible for making things. And it will have a getNextPoser method and a showPoser method and whatever else we need in order to make the trivia game work. And we want to set it up so that this is a little sealed subsystem that it creates no global variables of its own and has no leakage except for the methods that we choose to reveal. So we assign to Yahoo Trivia the result of this function. And here we define all the common variables that these methods are going to want to share and any common functions that they're going to want to use, helper functions or whatever. We can put those here as well. And then we return an object, which is these. And then we invoke that function. So what we're assigning to trivia is not this function, it's the result of calling this function, which is this object. And because of closure, these methods will forever be bound to these private variables and private functions. Okay. It's okay if you're confused right now. We'll make this clear at the advanced class. This is a really powerful platform that allows us to make our programs much more reliable. So one of the most controversial things about JavaScript is its type system. JavaScript chose to trade type safety for dynamism. A lot of people wouldn't make that trade-off, but that's the trade-off that they made. So JavaScript has no cast operator, which is a good thing. Reflection is really easy in this language because you can always look at an object and ask, what are you about? You know, do you have this method? Do you have this value? So reflection is easy in this language. And so you step back and you ask, well, why do we have inheritance at all? Why is inheritance important? I contend that we get two things from inheritance. One of them is automatic casting, because a type system in which you have to explicitly cast things, I contend, doesn't really give you any type safety. So automatic casting is important. But in JavaScript, we never cast. An object reference is always an object reference. So that doesn't get us anything. The other reason we want inheritance is for code reuse. And as we've seen and as we will see, JavaScript provides many, many patterns for code reuse that we don't need classical inheritance in order to accomplish those. So ultimately what JavaScript does is trade brittleness for flexibility. Is it a trade-off? Is it the right trade-off? I don't know, but that's the state of the language, so that's what we have to work with. I found over the years of working with JavaScript, I used to be of the religion that said, yeah, absolutely brutally strong type systems, figured it all out at compile time. I have now been converted to the other camp. I found that the expressive power in JavaScript is so great. I have not felt that I've lost anything in giving up the early protection, particularly since I wrote my own tools to make sure that I get some reliability anyway. We'll talk about that again later. For completeness, JavaScript has a date object. It was based on Java's date class, so as a result, it was not Y2K ready. It was only 1995. I guess they didn't see it coming, but they have since fixed it. JavaScript has regular expressions. It copies some of the Perl conventions. Regular expression literals are enclosed in slashes, which is a little problem syntactically since slashes already mean comments and division. So you have to be careful about where regular expressions can go. This is a regular expression which matches regular expressions. At least that's what I claim it is. There's really no way you can tell looking at it what it actually accepts and what it rejects. Regular expressions are a bizarre notation. I think they're really difficult to read. It frightens me that we rely on them so much for validation and for securing our systems when we have really no idea what this is doing. Doesn't seem to me the basis of any kind of system of security, but they're really popular, and so JavaScript's got them. And I use them a lot, but I recommend be really, really careful with them because it's really easy to get them wrong and you don't get much indication that you did. Threads are a way of doing concurrency. The JavaScript specification is neutral on threads, doesn't say it has them or doesn't have them. There are some language processors like the SpiderMonkey JavaScript engine, which does provide thread support. Most application environments, such as browsers, do not provide thread support. All of the browsers at the application level are single-threaded, which is really good because threads are evil. It's really hard to think well about threads. They don't belong at the application level, so it's just as well that we don't have them. JavaScript is provided on lots of platforms now. It's obviously in all of the browsers. It's also finding its way into operating systems now in Windows Script Host and in Dashboard on the Macintosh. It's in Yahoo Widgets, formerly known as Confabulator. It's got a JavaScript engine built into it. It's finding itself in desktop applications. Dreamweaver and Photoshop have JavaScript built in. PDF has JavaScript built into it now. It can be embedded now into virtually any application. So the time that you invest in learning JavaScript, it's going to be helpful in doing web development, but it's useful in a whole lot of other environments too. So I think it's definitely worth the trouble to learn it. A JavaScript-like language is ActionScript, which is found in Flash. This is a list of differences for ActionScript 2. A lot of the Flash community contends that ActionScript is an ECMAScript language. It's not. It's not compatible. Programs written for one will probably not work in the other. There is a newer language called ActionScript 3, which is in the current Flash, is also not compatible with JavaScript. And that's a problem for Adobe. They'd really like Flash to be based on a standard programming language. And the way they got to ActionScript 3 was there was a proposal for an ECMAScript 2 that was developed by Microsoft and Mozilla, or Netscape, I guess, at the time. But they couldn't agree on the details, and at some point they so enraged the ECMA committee that they didn't want any part of it, and so it never became a standard. Not knowing how it was going to turn out, Macromedia went ahead and implemented it anyway. And so they tried to get in front of the standard and instead unstandarded themselves again. One thing that did become a standard was E4X, the extensions to ECMAScript for XML. This is something that was proposed by BEA, and it provides for XML literals in the language. So any place you can have angle bracket things and write out expressions. It uses the @ sign for getting at attributes inside of XML expressions, sort of XPath type expressions inside of JavaScript. It's implemented in Firefox, but not most other places. And in particular, Microsoft has not implemented it. It's not in IE 7. Who knows if it's going to be in IE 8 in a year and a half. You know, as I always say, 9% is not enough. And the big problem with this is it's all syntax errors for the old JavaScript. So if you load JavaScript with the E4X features, you get a syntax error, the program doesn't run. If you get a syntax error, we don't get paid. So you can't if around this stuff because the compiler rejects it and it all goes out. So my advice is don't use E4X as much as you might like an alternative to the DOM interface, which is really horrendous. For most applications, this is not an alternative, which is too bad. Now, Microsoft had 3 people on the committee that standardized this. All 3 voted yes. So Microsoft cast 3 yes votes for the standard and then chose not to implement. So that one's DOA, or so it appears. Now there's some new activity going on, a 4th edition of ECMAScript. The 3rd edition was published in December of 1999. So the language has been sitting still for quite a long time. And so in that time, they've decided to take another attempt at creating a new standard based on it. A very large set of new features are being considered, including type declarations, classes, yields, deconstruction, a whole lot of stuff. Some of it is likely to be very popular, particularly for the people who don't want to have to learn to think differently. It might be possible to use this language that way. It's going to have an object model which is more Java-like. But at the same time, it's going to have to be compatible with the old model. And it's not clear if those 2 worlds are going to play where it can be completely loosely typed and strongly typed at the same time. One thing we do know is it's going to turn from a small language to a large language. I'm not sure this is necessarily a good thing. Mozilla is pushing this. Adobe is also pushing it very, very hard. Adobe wants it to be a standard. Microsoft is really not paying attention to it. So it's not clear if they're going to adopt this one either. And no word from Safari yet. They haven't paid any attention. But I'm guessing if Microsoft goes along, Safari will have to. But we don't know what Microsoft's going to do. Let's talk now about style. programming style isn't about personal taste. It's about rigor in expression, about clearness in presentation. It's about product adaptability and longevity. Good rules help us to keep the quality of our programs high. Style is important in all programming and all programming languages, but particularly in JavaScript. Because the language is so soft, because it's loosely typed, because it has errors in its design and some other factors, it's really easy for a program to collapse into a puddle of confusion if you don't have really strict style rules working for you, since so little else about the language is strict. So I've discovered that most of the world's body of JavaScript programs is crap. I believe that's
90% of everything.
well, it's particularly true of JavaScript. And it doesn't need to be. I believe it is possible to write really good programs in JavaScript, but it does require attention to style. So we're going to look at some code conventions that I've developed specifically for JavaScript. You can read about them at javascript.crockford.com/code.html. My ambition is to eventually turn these into Yahoo standards and have all of web development and all the JavaScript development at Yahoo conforming to these. I think it really will make us more productive and improve the quality of our code, which should ultimately make us all a lot happier as well. So these are some of the specific things I'm recommending. In JavaScript, when the compiler sees an error, it attempts to replace a nearby line feed with a semicolon and try again. This should freak you out. It can mask errors, so I recommend that you always use the full correct forms, including semicolons in all the right places. This was done intentionally in the language. This was an intentional error in order to make the language friendlier for beginners. Syntax is complicated. You don't know where all the semicolons are supposed to go. Don't worry about it. But JavaScript syntax is based on C, and C has semicolons for a reason. The grammar is ambiguous without semicolons. JavaScript has those ambiguities. It tried to resolve the ambiguities by aliasing line feeds into semicolons. So it replaced one ambiguity with another. Not generally a good idea. So be strict in your syntax. Because of semicolon insertion, you need to be particularly cautious with line breaking, because certain copy-paste errors are not detected by the JavaScript compiler. So I recommend that you always break a line after one of the punctuators, and that you not break a line after a name string or number or a closing operator or an increment operator. This will help detect certain errors easier or make them possible to detect. Avoid tricky expressions using the comma operator. And also don't use extra commas in array literals. This is the good way to write an array literal. This is the bad one. The difference is this one has a comma. Why is it bad? Because Netscape will tell you that the length of this is 3, and IE will tell you that the length is 4. And doing cross-browser stuff is hard enough without this kind of stuff getting in the way. I recommend that you always use blocks around structured statements. So this one is 2 characters more than that one, but this is provably a source of errors, particularly in large projects or ongoing projects or projects with lots of programmers on them. It's really easy for this one to get corrupted, whereas this one tends not to. So this resilience is well worth the 2 extra characters. Blocks don't have scope in JavaScript, so don't use blocks strictly for scope. So I recommend that blocks only be used in the structured statements and nowhere else. Define all of your variables at the beginning of the function. Since you have function scope rather than block scope, put them where you know they're going to be. In some languages, you like to define them as close to the site of first use as possible, and that makes a lot of sense in other languages. Unfortunately, it doesn't really make sense in this one. So some of the style rules I'm recommending are different from rules that you may have seen in other contexts, but that's because this language is different than other languages you may have worked with. JavaScript, like the C languages, has expression statements, but those can mask errors, particularly when you have semicolon insertion going on. So I recommend that the only expression statements be assignment expressions and invocation expressions. In no other case should you be using expressions as statements. So it's okay to call a function. I mean, you have to be able to do that. But using an AND operator here to control flow, I think is a bad thing. I'd rather see this written as an if. Avoid fall through in switch statements. Every clause should explicitly break or return or throw. Do not use assignment expressions in the conditional parts of ifs and whiles. The reason is that this is more likely to mean that. And so if you're in the habit of writing this form, it's really difficult to determine when the mistake occurred. So it's much better to never do this. Be aware that double equal and not equal do type coercion. So this statement appears to do what this statement does, but actually does what this statement does. So a statement which appears to do one thing and does another can lead to errors. So I recommend figure out which of these you mean and write this one, whichever one it is. In some cases it means putting in an extra equal sign. I'm happy to pay one more character in that case. If you're just looking for a value which is falsy, then this form's actually smaller and faster, so you're better off with it. One place where I've seen this one used is they pull A out of an object, and they look to see if it's null. But the thing they were really looking for was undefined, but they were confused about the difference between null and undefined. So they actually had two errors that canceled each other out. That's a bad way to program. It's better not to be making so many errors. Only put labels on the statements that make sense with labels, so do, for, switch, and while. And never, ever use JavaScript : as a label. And also avoid as much as possible using JavaScript URLs. That, I think, was a bad idea in the browsers and something we should try to get away from. So JSLint is a program which will check for all of these things and will provide an automatic search for all of these and will help uncover errors in your program. Also give you a map of all the variable definitions in your program showing which are bound enclosures and which aren't, and give you a list of all of the field names that are used in your program. This can be extremely helpful in improving the quality of your programs and can also be helpful in debugging. JSLint does all of that. It can find things which are really hard to find in debugging. It provides a lot of the safety that we liked strong typing for, even though we don't get strong typing in this language. Having automatic detection of errors is really a helpful thing. JSLint is available as a web page, so you can just paste your program in it and it'll check it locally. It's also available now as a confabulator widget and can also be run in the desktop. It's getting built into text editors now. It's going into Eclipse. So again, I highly recommend that you be running all your programs through JSLint. One warning though, JSLint will hurt your feelings. Bad. It is a cruel, arbitrary program, but if you can stand it and listen to its advice, it will make your programs better. So to wrap up, these are what I think are the key ideas in JavaScript. Load and go delivery, in which programs are delivered as text. Loose typing, which takes some getting used to, but I think is a very powerful thing. Objects as general containers, which I think was brilliant. Prototypal inheritance, which turns out to be a pretty useful thing. I mean, it's why JavaScript is succeeding in the thing that Java was intended to do and failed at. Lambda, which is probably the best idea in the history of computer science, and linkage through global variables, which is probably the worst idea in the history of computer science. It's all there in one language. It's JavaScript. We'll continue next week with the theory of the DOM, and the week after with advanced JavaScript. I hope that you'll all come for those. I'll see you next week. Good night, everybody.